Hello friends, this video is about Tower of Hanoi problem. I am going to show you how to write an algorithm for Tower of Hanoi by taking a small example as well as large example with 3 disks. The problem is there are 3 towers given and one of the tower is having a stack of disks in the decreasing order of the sizes from bottom towards top. We have to move all this disk from tower A to tower C. And at any moment of time, a larger disk should not be kept over a smaller disk. So this will not be easy to transfer all these disks. So for help, one more auxiliary tower is given, which we can use for transferring this disk. There can be any number of disks given in this tower. So let us see how to solve this problem by taking a small example. I am taking one example with a single disk. Suppose there is only a single disk given in the tower. Then the solution is very easy. Move a disk from tower A to tower C. Now next, if there are 2 disks given, disk 1 and disk 2, then the first move will be move a disk from tower A to tower B. As we are not moving into destination tower, we are moving into an auxiliary tower, that is intermediate tower B. So I have written the statement like this: move a disk from tower A to B using C. I am saying this is done. Now second move is move a disk from A to C. So as it is a destination tower, so directly move a disk from A to C, and this is done. Now third step is move a disk from B to C using A. So here I am not starting from source or the beginning tower, I am starting from B, so I am again using the term using here. So B to C using A, B to C using A. So this is how the statements are framed. And finally this is moved. So these steps were very simple. If there are 2 disks are given, then the problem is very small, it's very trivial. And these are the 3 steps. Now let us move to the next problem. If there are 3 disks given, now we can call this problem as large. This is a little bit complex. Now if there are 3 disks, I am going to give the moves like this. Move 2 disks from A to B using C. Actually we have to move 1 disk at a time, but here I am saying move 2 disks. How to move 2 disks from one tower to another tower, already we have seen it, so you can apply that procedure. So it means this statement is a recursive statement. So it's not talking about 1 disk at a time, here it's talking 2 disks at a time. So how to move to 2 disks, we have already seen the procedure. So let us see this, and these 2 disks are moved here. This is done. Second step is move a disk from A to C. Move 1 disk from A to C. That's it. It's done. Then third step is move 2 disks from B to C. These 2 disks we have to move from B to C using A. Again this is recursive step. How to move these 2 disks from this tower to this tower, already we have seen. So this is recursive step. And finally this is done. Now these 3 steps are very important for devising a recursive procedure for Tower of Hanoi problem. If there are n disks, then those 3 steps can be written like this. When there were 3 disks, we wrote here 2. So it means if it is 4 disks, then we'll write 3. So similarly, if there are n disks, we write n minus 1. So those 3 steps are repeated here. Move n minus 1 disk from A to B using C. Move a disk from A to C, and move n minus 1 disk from B to C using A. So this forms our recursive algorithm for Tower of Hanoi. Now here is an algorithm. Here you can compare it with these 3 steps with the algorithm. n minus 1 disk from A to B using C, and move a disk from A to C, n minus 1 disk from B to C using A. The algorithm is, if there are n disks and 3 towers are given A, B, C, and if there are more than 0 disks, then first step, n minus 1 disk. Here B is the middle tower which we are using, so I can call it as using. So now in this step C becomes using, so C comes in the middle. Source, destination, this is middle one. So source, destination, this is the middle one. And next step is printf moved is from A to C. That's it. And third, n minus 1 disk. This is source, this is destination, this is middle tower. So source, destination, and this is middle tower. So this is how the algorithm is devised based on the 3 steps we have seen. Here I am going to trace this algorithm for 3 disks. So this algorithm or a function is called by passing 3 disks, and tower numbers are given 1, 2, 3. Now inside the algorithm there are 3 steps. First is a recursive call, then printf, then again a recursive call. So I am not going to show this tracing in the calling sequence, but I am just going to expand this. Now here you can see when 3 disks are passed with 1, 2, 3, then there are 3 steps. n minus 1 A, C, B. So n minus 1 is from 3, it is 2. A, C, B. So 1, 3, 2. The next is printf AC. Printf AC. 1, 3. Then again a function called recursive call n minus 1 BAC. So 2, this is B, this is A, and this is C. Then again these two recursive call has to be expanded. So they are expanded like this. Alright. Now we call this as A and this as B and this as C. Based on that these calls are written. Again these will expand. So this is how it looks like. As after 1 disk, the next call will be for 0 disk, and nothing going to happen when there are 0 disk. So that's why I have put a mark here to show that it terminates here. Now finally, in this complete tracing, these are the printfs. I have collected all of them here at the bottom. 1 to 3, 1 to 2, 3 to 2, 1 to 3, so on. Now these are the moves that we have to take for transferring or moving 3 disks from tower A to tower C. So let us see whether these moves will really help us in moving 3 disks from tower A to tower C. Here are the steps or moves. The first move is 1 to 3. So we'll move 1 disk from tower 1 to tower 3. This is done. Then second move, tower 1 to tower 2. This is done. Third move, tower 3 to tower 2. This is done. 1 to 3, 2 to 1, 2 to 3, then 1 to 3. That's all. We have followed all these moves and we have transferred all these 3 disks from tower A to tower C or tower 1 to tower 3. So that's all. This is the tracing for 3 disks. Now similarly this algorithm can work for n number of disks. Hope you have understood the working of Tower of Hanoi. Thank you for watching.